Okay, so we're slowly adding parts, and we've taken this transceiver one by itself under the sheet, cropped, turned it on. It's lined up where it's over where the ceramic hole is, so we can add the pencil beam. And now it's time to move to a bigger structure, which just includes more of what we're proposing to create. And again, remembering that this is the cylinder wall with this linear array of transducers or transceivers glued to this array of ceramic discs. And this is the piston head, and it has a smaller linear array of transducers glued to its piston wall. And obviously this would be turned so that this set of transceivers is shining through this piston head into that set of transceivers. And we're going to go over here and take a look at that configuration. And you can see that on the piston head, I have the double transceiver, or excuse me, double ceramic setup. I've actually sort of got a double transceiver setup, and this was put together to address the issue of what to do if the piston head rotates a little bit, to see if there's a way to prevent the rotation of the piston head from knocking out the accuracy of the measurement. And it's a separate issue. I don't know if I'm going to get into it too much, but what we can say is that if we redraw this to this configuration, where you have what I'm calling the lower transceiver plus the ceramic, so that's this. So the lower transceiver plus these ceramic inserts. So these are the ceramic inserts that would be present in the wall of the piston head, and this is the ceramic that would be present in the wall of the cylinder. So when the lower, so we'll come back over here. So when the lower transceiver plus ceramic decides that it wants to say something, then the lower transceiver plus ceramic sends out a signal, which goes up through the ceramic in the piston head and through the ceramic in the cylinder wall, and the radio frequency output of the lower transceiver goes through all this ceramic and is heard or seen or interacts with or sends an information package to the upper transceiver. And again, if the what we're calling the upper transceiver plus ceramic wants to reply back, then the lower transceiver plus ceramic turns itself off, and the upper transceiver plus ceramic would beam out its radio wave, and that radio wave would, our radio modulated radio output at 60 gigahertz would allow the upper transceiver to send radio frequency energy and data from this place, which is outside of the cylinder, to this place, which was inside the piston, which is inside the cylinder. And we'll go over here, and again, this is just a drawing of the array of transceiver heads that I have inside of the piston. And again, this concept is working through if there's a way to have the piston so there can be a electronic compensation or adjustment so that the accuracy of the position sensing continues to be present even if the piston head rotates a little bit. And we're going to come over here and show you that this is what we refer to as the demo of this happening for real. These are little pistons that we're getting ready to move back and forth inside of these cylinders.